you're having trouble with a little bit of 7.6 homework, number 43 and so on. So here's going through 44 and such. So you want to solve the equation. If it has an x in there, that means you're solving in terms of radians. So that's like pi halves, pi thirds, pi sixths, those kind of things. If it's an exact number, all right. And in degrees, if you are in degrees, if you are in theta, which ours is on 43 and 44. So, and I'm going to do approximate when I don't have an exact solution. Okay, so that means when I get answers of like what is tan inverse of 1/2 or tan inverse of 1 or something like that, I can find those answers, right? Those are on the unit circle. I can do the left-hand method backwards in order to find those. Oh, so as long as I can do that, then I don't have to use a calculator. Okay, so here we go solving this one. I'm going to subtract 1 on both sides because I need to get the trig function by itself. So I have tan of theta equals -1. So then I can go ahead and find the inverse, right? So this is asking what is the angle that gives me an answer of -1/2. I can just answer that question, or I can take the inverse, just tan inverse, switch the x and y, right? Switch these two. So that's what this is asking. It's saying what is the angle that gives me -1/2 as an answer for in tangent, right? So if we look at tangent, tangent, if you're doing the left-hand method, it's right over left. So what finger do I have to put down in order to get the same number on my right hand as the left hand? Okay, so that'd be the middle finger, right? So that middle finger is either pi force or it is 45 degrees. And we can see that right here as well, right? At this point right here, my y value is the same distance as my x value. Well, that's probably not the best drawing, but this height is the same as my length here. Okay, so that's at 45 degrees. It's √2/2, comma √2/2. There's my y, there's my x. Tangent's y over x, so that would give me a +1. But I want a -1. Well, where's tangent negative? Second and fourth quadrants. So if we use this reference angle of pi force or 45, since we're in theta, we're talking about degrees, so 45 degrees. I go down 45 degrees, which is 315. And I go from 180, I go backwards to 135. I just use that as a reference angle to get to -1. So my theta is 135, and my theta is also 315. And so that is number 43. Okay. Sorry, I guess it's 44. So that's like 43, sorry. I guess I also didn't answer using least positive negative measures. So the smallest one would be the 135. So I guess I don't need the 315. So least, that's why you should probably read all directions, right? So 135. And then if you're, there's also a point. So 135 is the angle. And then all exact solutions. So when they say all exact solutions and they don't give us any parameters, that means because around the unit circle, I can just keep on going 360 degrees. So I can keep on rotating 360 degrees every time, right? Or because it's tangent, I only have to go 180. So I go 180 and I get my answer, right? -1. I go another 180, get my answer. So my answer for all solutions, exact solutions, is 135 degrees plus n just represents any integer, times 180 degrees. So that means if I go 135 is my answer, right? If I go one spin of 180, that'd be adding 180, which would get me to 315, which we already saw is the correct answer. If I put a 2 in here, I would get 360, right? 360 plus 135, isn't that just a full rotation? I'd get the same answer. Another 180, 3 180s right here, answer. 4 180s, 5 180s, 6 180s. So this is for all solutions. Okay. Let's see about 71. Trouble with 71, so I'll do 72. So this actually does give us parameters. If we're talking about x in radians, or if we're talking about theta in degrees. So here's, we do have parameters. So we're not talking about all solutions, right? Because we have 0 to 360. Okay, so figuring out this one, we're going to get that by itself. So divide by 2 root 3, divide by 2 root 3. So we get sine of 2 theta, so not quite theta yet, equals 1 half, right? Because these would cancel. Okay, so we can solve this, but we're solving for 2 theta, right? And our theta is actually between 0 and 360, so that means 2 theta would be double that, right? So we got to find answers between 0 and 720 degrees. Okay, so we'll take the inverse of this. So sine inverse of 1 half, meaning what angle do I get when I take this, when I get a 1 half for sine? What angle of sine produces a 1 half? Okay, we probably can use our left-hand method, or we can look here. Which finger do you have to put down to get a, this one would be four fingers to the right, 4 fingers to the right. Or sorry, not 4, yeah, 4 fingers to the right. So, or you could do which one, oh, would be a smaller up this way than it is this way. So which angle gives you your height is smaller than your length? Well, that would be 30 degrees. So not 4 fingers, that would be 1 finger to the right. So that'd be pi 6 or 30 degrees. But because I'm looking for a positive 1 half, well, sine positive 1 half is also over here. So we're looking at 150 degrees. But we want all the way to 270, right? So that'd be from 30 degrees, another full 360 degrees. So that's 360 degrees. And then another 360 from this one. So that'd be 410. If I'm doing my math correct. 510. 510, oops. 510 there. So 510. Okay, so here are my answers so far. 510, 510 degrees, 300 and 390. Jeez. And then 150 and 30. So that's all the way from 0 to 720 because I'm double my theta, and my theta was from 0 to 360. Okay, now this is all equal to 2 theta. So I now just divide all those by 2. So we get theta is equal to 30 degrees, 75 degrees, 210 minus divided by 2 is 150, 165. 195. Okay, so 255 and 195. So those are all those 510, 390, 30, and 150 divided by 2. Okay, so those are our answers. So you're going to do the similar thing here too. Double your range, and then solve for the double angle, and then once you have all those answers, divide all those by 2. 873 is similar as well. This is solving for half angles, so I'm going to get the half angle by itself first. This one I'm going to get the 4x by itself, okay? And so this one, since it's 4x, and solving for x, I'm going to times these by 4. So that's still going to be 4x, and my range is going to be from 0 to 1,000 something, 24, maybe. 72 times 2, 140. I'm off on this. Right. 1440. Advantage of having a calculator. All right, so that's where my range is going to be in between. So where's tangent 0? Well, tangent is 0 just uh, at 0, right? Tangent of 0 is just 0. And it is also 0 right here, right? So at 0 and at 180. But I'm going all the way to 1044. So I got to do the calculator again. So this is going to be 0, 360, and then 720, and then 1,000, 1,024, and then 1440. Right, and then just basically half as much as those, right? So 180 plus a 360, then plus another 360 and 360 and so on. So 540. Finally found my calculator. 900. Oh, and it's X. So really I'm looking at, and so that'd be last one, because if I add another 360, that's going to be over the 1440. This is actually looking at radians, right? Because it's 0 to 2 pi, because I'm talking about X. Okay, so that's not too big a deal. So that'd be 0, that'd be 2 pi. It's actually easier, 3 pi, or 4 pi, sorry. 2, 4, 6, and 8 pi, right? And so this would be 1 pi, 3 pi, 5 pi, and 7 pi. Okay, and then we're just going to all divide those by 4, right? Because this is 4x. 4x is equal to all of these. So I'm just going to divide them all by 2. So I get pi fourths. X equals pi fourths. X equals pi halves. 2 pi divided by 2 is just pi. Sorry, just pi. Yeah, pi halves. 3 pi divided by 2 is just 3 pi over 2. 4 pi, that's just pi. 5 pi, be 5 pi fourths. Then 6 pi, that's 3 halves. Uh, so I guess probably should leave it as 6 pi over 4. And then 7 pi over 4. And then 8 pi over 4. So look how many answers are 1, 2, 3, 4, 5, 6, 7, 8. 8. So normally on from 0 to 360, there's going to be, oh, I forgot 0. 0 or this one. I guess my parentheses is here. So this one wouldn't be in the list, but 0 would, because it starts at 0. So 0. So notice I have 8 answers here. And so normally I only have 2 answers right here. But because this 4 out here, it's going to quadruple my answers. So that's how you can always do with whenever there's a whole number out here, 4 times x, 2x, it's always going to double your normal answers. So those are all my answers there. All right. So here, solving this one. Looking at this problem again, this is looking at x, so we're looking at from 0 to 2 pi, starting at 0 and going almost to 2 pi, right? And so here, what we want to do is we'll go ahead, and one way to do it is to factor out I was going to say factor, but not factor yet because it's not a squared yet, but I can replace this double angle of cosine with that actually what it equals, which is 2 cosine squared x, and then minus 1. And then I'm subtracting a cosine x. Now I can kind of treat this as a quadratic, right? 2 cosine squared x minus cosine x minus 1 equals 0. So now it kind of looks like a quadratic, right? Cosine is my middle term. And right here is that middle term squared. So here's my a. like 2x squared minus x minus 1 looks like a quadratic equals 0, right? This is just cosine squared. This is just cosine. You can do u if you want, or you can look at this as just this is being the first, this thing being squared. So here's my a, -1 is my b, -1 is my c. So what are the factors of -2 that add up to -1? Well, that'd be -2 and a +1, right? So that's cosine x minus 2 times cosine of x, because that's basically what my variable is, right? That's cosine x, and then +1 equals 0 equals 0. Those are my two factors, -2 and +1. So now I can solve these. So cosine x equals 2 and cosine x equals -1. Well, this is not possible, right? I can never have an answer. There's no angle. It goes from 1 to -1, right? So I'm never going to have an answer of 2. So that one's not going to work. Where do I have -1? -1's right here, right? So, but from 0 to 2 pi, not including 2 pi, but including 0, where do I have an answer of -1? Well, that's only one spot, right? That's only at pi. So for 76, my 76, so you'll use the definition of what sine of 2x is, and then solve it with a quadratic. Okay, just like I did there. Set it equal to 0, treat it like a quadratic. So on 76 there, um, we're looking for answers for 0 to 2 pi of where it is. Oh, what did I do wrong? I forgot to divide by my 2. Right, so I have to divide these 2 by 2. So that actually equals -1. Cosine x equals +1. So where's it +1? Well, that's at 0, right? And where is cosine x? I have to divide this by my a, right? I forgot to divide those by my a. So I should have divided those two by my a, which was 2. Sorry about that. Equals -1. So where's cosine -1? Well, pi sixth would be sine is 1/2, right? So that means that pi thirds would be cosine is 1/2. So pi thirds cosine is 1/2, but I want a negative, right? So that means I need to be on the left. So that's -2 pi thirds. Not -2 pi thirds, but 2 pi thirds would give me a -1/2. And then I keep on going from 0 to 2 pi. I want to be at a pi thirds to pi. That'd be a 4 pi thirds. So those are my three answers: 0, 2 pi thirds, and 4 pi thirds. All right, so there you go for that one. Do you need 88? I think you might have 88. Let's see. No, you need 88 too. Okay, so this is kind of the same one as before. We're going all solutions, unless we don't have it on our left-hand method. Okay, so we get this by itself. Okay, so I noticed that this answer isn't something we usually have around the unit circle, right? If I rationalize this, this is just 3. It's going to cancel out that one. So I get a negative root 3 over 2. Do I have negative root 3 over 2? Do I ever get an answer of root 3 over 2 with cosine? I do, right? I get a root 3 over 2. That's at pi 6, right? So I do actually have these. I was thinking not. Okay, so I'm just solving for this, right? So because the cosine is now by itself, I can go and take the inverse. Negative, though, root 3 over 2. So again, I'm looking at the second and third quadrant. And that answer would be, like I said, pi sixth. But it's negative, so that'd be, and again, I'm with x, so I'm in radians. So 5 pi sixth and 7 pi sixth. But it's x over 2, right? So that means I need to multiply these by, this is not a point. I need to multiply this list by 2, right? So I need to multiply each of these by 2. So I can reduce that to 5 pi thirds and 7 pi thirds. And so that's where my x is, around there. And then the last one. Oh, again, I need to go, it's repeating, right? So those are my answers from 0 to 2 pi. Now I need to repeat myself. So these answers repeat themselves. What was I doing? All solutions, okay. So all solutions. So these keep on repeating themselves every 2 pi, right? Not quite 2 pi, because normally it's when it's just x, I get my answers, right? So normally it repeats itself every 2 pi, right? But because it's x over 2, I need to multiply both of these by 2. So it's actually every 4 pi that these are going to repeat itself. So I had to add 2 pi n to this and plus 2 pi n to this. So those are actually my answers for all solutions. If it just wanted from 0 to 2 pi, then I would be 0 to 2 pi would kind of be expanded a little bit as well. But so those are all my solutions. All right, last one. Man, it's kind of a long video. Probably because I keep on messing up a little bit, huh? Why am I trying to change that? See, there's another mess up. All right, anyways, 96. So again, doing the same thing. All solutions. So where do you see the definition of this? So is that for a double angle of sine? But usually it's 2, right? It's 2 sine theta cosine theta. So really that's just, I could divide both sides by 4. This would be 2 sine theta cosine theta. Okay. And that, if you can look back in 7.4, 7.4, I think 7.4 is all the different double angles, and that's the double angle. That's the double angle of sine. And so we'll go ahead and use that double angle of sine. So this is the double angle of sine. So sine of 2 theta, cosine of 2 theta. Okay, so this is asking, where is sine of 2 theta equal to sine of 2 theta? Right, so where on the unit circle is your sine and cosine have the exact same answer? Well, that's at 45 degrees, right? 45 degrees would be there. And then if I go to, that's positive. And then if I'm just repeating myself, but this answer is for 2 theta. So that means I have to divide this by 2. So that means I'm at 225, or I will be at 225 by 22.5 degrees. Okay, but I want all my answers to be in a range. So normally it would be 22.5, right? And then I would just add on to this like plus 360n, but it's not 360 anymore. I have to divide by 2. Divide by 2, it's going to be 180, so 180 degrees n. And so that's going to be a repeated answer. So that's where I get the positive from. Another way to look at this is, oh, well, I'll also get at 225 as well, right? So 225 as well, divide that by 2 is 111.5, or 112, sorry, 112.5. So 112.5 degrees plus 180 degrees N. So those are your two answers. You can look at another way if I divide both of these by cosine 2 theta. 1 equals sine of 2 theta over cosine of 2 theta. Sine over cosine is tangent. So this is really tangent of 2 theta. So where is tangent 1 at? Or you can do the inverse now. Tan inverse of 1 equals 2 theta. That would be at 45 and at 225, right? Like I did. But that's 2 theta, so I have to divide those by 2, like I did. And then since we want all solutions, normally it's every 360, but because it's 2 theta, we'd have to divide that and we get 180. So instead we add 180 to each side. So there's two ways to look at that. And that is all done. Sorry I took forever on that. At least it's under 30 minutes.